In this question, we have to prove that the function f defined from n to n, that means that here the domain being a natural number, all natural number, and the range also being a all natural number, and the function is defined as fx is equal to x square plus x plus 1. We have to show that it is 1, 1, but not an onto function. So let's begin with proving this as 1, 1 functions. So to prove this as 1, 1 function, what do? We say let fx1 is equal to fx2, where x1 and x2 belongs to all natural number. Now replacing fx, this function fx with fx1, what we are going to get as x1 square plus x1 plus 1 is equal to, replacing this function by x2, we are going to get x2 square plus x2 plus 1. So what do you see that here, this 1 get cancelled, right? We are going to cancel this. 1 and 1 get cancelled. Now keeping x1 square minus, this is x2. x2 square, similarly x1 minus x2 is equal to 0. Now if I factorize using the identity a plus b, a minus b, we are going to get x1 minus x2, that multiplied by x1 plus x2 plus x1 minus x2 is equal to 0. Now you can clearly see that x1 minus x2 is common. So if I do so, if I take x1 minus x2 as common, what we are getting? x1 plus x2 plus 1 is equal to 0. Now check here that x1 and x2 are natural numbers. Here x1 and x2 are natural numbers. So clearly the sum of two natural number plus 1 can never be equal to 0. So therefore, we need to write down this cannot be 0. We need to write down this cannot be equal to 0. So clearly, if this is not equal to 0, this can be 0. The difference of two natural number can be 0. So we can say that x1 minus x2 is equal to 0. This implies that x1 is equal to x2. And once we prove this, we say that this is hence it is an onto, sorry, 1, 1. Now, in order to prove this function as a surjective or not, we have to prove that it is not. So what we do, first we say let y is equal to fx. So we consider this y, fx as y. So replacing this fx with y, what do we get? Y is equal to x squared plus x plus 1. Now, let's say if I take the smallest natural number, let's say if I take x is equal to 1, and you know that here x, which is a natural number, right? 1 being a natural number, 1 belongs to a natural number that is from domain. I've taken from the domain. Now replacing x with 1, what I'm getting? Y as 1 square. 1 square is 1. 1 plus 1 plus 1. So y we are getting as 3. Now, if I take a value of a natural number that belongs to domain higher than 1, like 2, 3, we are going to get a number which is greater than 3. Let's say, for example, if I plug in 2 here, that is 2 square is 4 plus 1, 5 plus 1, 6. So what do we see here? That for x belonging to here, what you can see that here the values of y which we are getting is equal to 3 to positive infinity. Right, but this is the range, right, which is equal to the range. This is range is this, that is 3 to infinity. But what is the codomain? Codomain is all natural number. As you can see here that the codomain is all natural number. So you can see that the element 1 and 2 is not the image of some elements in the domain. So we'll say that since the range is not equal to, we'll write range is not equal to codomain. Therefore, it is not an onto function, not an onto function, right? As you can see clearly that the our codomain codomain is 1, 2, 3, 4, and so on. But the element 1 and 2 is not the part of the range, or we can say 1 and 2 are not the image of some element of the domain, and that's why it is not an onto function.